So we've talked about some of the organization of the visual system. We've talked about contours. We've talked about depth and size and so forth. But how do we get from that to actually making sense out of a visual mess like this, where nonetheless we can actually distinguish objects and recognize objects? Well, in order to recognize objects, the first thing we need to do is figure out how we actually create some sort of perceptual organization. Out of this whole mess, how do we figure out where certain objects start and end, and so forth? So, perceptual organization, one of the things that requires is what you call perceptual segregation, meaning how can we make out individual objects out of this clutter of visual information that we get? Because that visual information, the light that's falling on your retina, right, the back of your eyeball, that doesn't necessarily give you any idea of where something starts and ends. In this picture, for example, right, you figure out this is a computer monitor, there's some sort of pill bottle here, there's a lot going on. There's nothing inherent in this input that helps us actually determine that this white part right here is a different object than this white part over here. So how do we organize visual space? Well, there's a long tradition of studying this, and some of this happened in Germany, and they came up with a couple of organizing principles that are all sort of classified under Gestalt psychology. And the Gestalt, or in Dutch a Gestalte, similar word, is kind of like a general organization. So what these guys were looking for was very simple organizing principles that could help how the visual system made sense of the visual input. The basic law underlying this is what's called the law of simplicity, or if you like German, Prägnanz. So simplicity, if you want to say something about what that means, Kafka said about simplicity the following: of several geometrically possible organizations, that one will actually occur which possesses the best, simplest, and most stable shape. So in other words, the brain will sort of extract simple forms over more complex forms. Now, you might ask, well, that doesn't tell me anything, because this is just kind of moving the question. You've now answered the question, how does the brain perceive something? Well, it perceives it because it's the simplest way of perceiving it. Well, what makes it so simple? Of course, they realized this too, so they did a little more than this and then identified some grouping principles that then actually kind of states and make explicit what they mean by simple. So there are a couple of those that I want to go through. A first one is the law of proximity. And the law of proximity simply states that things that are closer together are more likely to be part of the same objects than things that are farther apart in the visual space. And you can see this very easily. I bet you here that you guys just see a square of dots because they're all sort of at the same distance from each other. Whereas here, most of you probably see, if you want, three objects: a rectangle with dots here, then some space, then another rectangle of dots here, then some space, then another rectangle of dots there. Those dots right here are grouped together because they're so close together in visual space. Then there's a break, and there's another set of dots grouped together. So the visual system, based on proximity, assumes that there are three objects here. So that seems to work pretty well as an organizing principle. A second principle is the law of similarity. And that law states that elements with similar features, such as color and form, are grouped together. Again, simple demonstration. I bet you that you guys see a line of white dots, a line of black dots, a line of white dots, and a line of black dots, and so forth. I doubt that any of you saw one line of white, black, white, black, white, black, white, black, and then another line of white, black, white, black, white, black. Well, why is that? These objects, these white dots, are all highly similar, and they get grouped as if they were one object. Then the same for the black line, then the same for the white line. So that's the law of similarity, and it's actually, again, it's a very simple principle, right? The law of simplicity states that the organization we perceive has got to be the simplest possible. Well, similarity helps with that. Things that look similar tend to go together in visual space. A last organizing principle is the law of good continuation. And this law basically states that we perceive the world in sort of smoother lines rather than in terms of really jagged edges. And I can demonstrate this easily too. So if you were to see this display right here with 4 of these little strings and a block that's occluding some of it, if I had asked you, hey, this string part up here, which one of the other 3 do you think it connects to? Most of you guys would probably have assumed either this one or most likely this one, because that's the sort of smoothest continuation of where that line is going. So most of you would perceive this to be connected to the one over here and this one to be connected to the one over there. There's nothing to say that you couldn't have perceived it as this line continuing and then making a very sharp edge and being connected to this right here. But the brain doesn't do that. We sort of favor good continuation. We're favoring more smooth lines in the world than more jagged lines. And part of this is because that's how most of our world actually happens to be organized. So these are 3 principles that help us with organizing visual space. Now, once we've used these principles, now maybe we're able to actually figure out what part of a visual scene is the same object. And then the next question would be, once you know where an object kind of starts and where it ends, how do you now use your visual system to actually identify what the object is? So that's the next part. How does object recognition actually work?